Welcome to the lecture series on fundamentals of electric circuit. In this particular lecture, we are going to discuss on a very important method that is used to solve a circuit that is named as nodal analysis. In this particular technique, we make use of two different laws that is one is Ohm's law and second one is Kirchhoff's current law. This both of these laws that are being used together to write the equations. Now in this nodal analysis, the equations will be in the form of the equations will be in the form of nodal or node voltage. What do we mean by this particular sentence? When we make use of both of these laws to write the equation, the unknown variable of that equation is going to be the node voltages for each nodes that are present in the circuit. So let us just go briefly on what these two laws are actually. So we have been studying this Ohm's law for quite some time. This Ohm's law states that the current that is flowing through a circuit is directly proportional to the voltage across it. Or in other words, we write V is equal to IR, voltage, and I is the current and R is the resistance. Let us assume that we have a resistor of value R. Now this resistor has got two terminals if we take. So let us call this left terminal as VA and the right terminal as VB. And what we are going to assume that, just for the sake of writing the equation, we are going to assume that the current is flowing from the node A to node B. Now from our very fundamentals of electric circuit, we know that the current always flows from higher potential to lower potential. Therefore, the voltage VA must be at high potential. Then VB, then only the current is going to flow from the node A to node B. If this is the case, we can write the expression for I as VA minus VB divided by R. And the same equation also makes sense from this Ohm's law. I is equal to V by R. So the voltage will be in the numerator and denominator is the R. So this is the one of the form of the current equation that will be using more often in the nodal analysis. That is sufficient for this analysis. Now the second law is the Kirchhoff's current law. This is also very important. Now what this Kirchhoff's current law states that in a particular circuit we have to look at a node. Let's say for example we consider a node, and to this particular node there are, let's say for example, 5 different branches that are connected together. And in each of the branches, let us arbitrarily assume that there is some value of current that is flowing. So in each of the branches we have marked the direction of current. Now let us arbitrarily name the number this. So I1, I2, I3, I4, and let's say the fifth one is I5. So what this Kirchhoff's current law states that at a particular node we have to sum all the incoming current. So sum of or we can say sum of, we can write directly sum of all incoming current. Sum of all incoming current will be equal to sum of all outgoing current. Outgoing current. Now from this particular circuit, we can see that since there are all put together 5 different branches that is connected together to this node, we can see here that there are 3 different current components that is incoming to this node, and those currents are I1. So I1 is incoming. I3 is again another current component that is flowing towards the node, and then we have got the fourth current component that is I4. And then when we have summed up all the incoming current, that will be equal to sum of outgoing current. In this case, the outgoing currents are I2 plus I3. So this is the expression, and this is the definition. The sum of incoming current is equal to sum of outgoing current for Kirchhoff's current law. Now, to understand this nodal analysis, let us go to the bottom of the page. Okay, we are already the bottom, so we add one more page. And then to understand, let us consider one example. So let us consider this circuit shown in the figure, and we'll try to write the voltage equations using the or the current equations at each of the nodes using the nodal analysis. So let us focus on the method itself. So if you can see here the circuit, we have got 5 different components that are connected to in a certain form. So here we have got 3 different resistors, 2 ohm, 4 ohm, 6 ohm, and 2 independent current sources. Now the first step in the nodal analysis is to locate all the possible nodes. So here in the circuit we can see there could be only 3 possible nodes. One first node, second node, and third node. Once we have located, the next job is to connect one of the node to ground to make it as a reference node. So normally the conventionally what we do, we connect the bottom node to ground. So once we have connected this node to ground, this node is now known as a reference node. So this node is known as a reference node. Reference node. Now once we have connected one of the node to ground, now we can see here there are other 2 nodes. These remaining 2 nodes are known as non-reference node. Okay, before that, what will be the voltage of the reference node? Yes, it is equal, it is going to be equal to 0 because it is connected to ground. Now the next step is to write the value of voltage of each of the non-reference node. So let's say for example, we call the voltage at first node as V1, second node as V2. Okay, so we have marked the voltage of each of the non-reference node. Now next step is to arbitrarily mark the direction of current in the branches. Now if you see here the 2 branches with the independent current source, we know the direction. The branch with 5 amps current source, it is flowing from node 2 to node 1. The branch with 10 amps of independent current source is flowing from a reference node to the node number 2. However, for the remaining branches with the resistors, we don't know the direction. So we will arbitrarily assume The branch with 2 ohm, let's say the current is in downward direction. Branch with 4 ohms resistance, it is from node 1 to node 2. With 6 ohms, let's say it is again in downward direction. It is totally arbitrary in nature. It's up to you. If you want to consider in upward direction, it's totally fine, no problem. Now, once we have marked the direction, next step is to consider one node at a time and apply the Kirchhoff's current law at each of the non-reference node. So let's say, considering the first node, applying Kirchhoff's current law at node 1. How do we apply? In sum of incoming current. Now there is only one current component that is incoming to the node 1, that is this 5 ampere. So 5 is equal to, is there any? No. So and then outgoing, we have two other outgoing current component. Now we'll write the value of current in the branch of 2 ohms resistor. Current flows from high to low. We have seen in the previous slide. Let's Then we can write V1 minus 0 divided by 2. That's it for the branch with 2 ohm. Then the value of current in branch with 4 ohms, it is going to be V1 minus V2 divided by 4 it is. Now the next step is to simplify it. Once we simplify, we are going to get V1, 3V1 minus V2 is equal to 20. And this is going to be our first equation, question number 1. As you can recall from the previous slide, what I said, that in the nodal analysis we make use of Kirchhoff's current law and Ohm's law. So if you see this, how we have written this particular equation is with the help of Kirchhoff's current law, and this each of the terms in the right hand side is representing the Ohm's law. And this second important point is from the equation number 1 itself. If you see, the unknown variables are in the form of node voltages. So whenever we solve a circuit using nodal analysis, the unknown parameters is going to be the node voltage itself. Fine. So let's now proceed and write the current equation for node number 2. So applying ACL at node 2. For node 2, we have got two different current components, that is incoming. One with 10 amps and another one is in the branch. Look at this branch with 4 amps. Current for node number 2, the same current is incoming. So it is going to be V1 minus V2 divided by 4, and then equal to the sum of outgoing current. So 5 plus V2 minus 0 divided by 6. Post simplification, we are going to get 3 minus 3V1 plus 5 V2 is equal to 60. So this is the second equation. And the next step is to make use of calculators to find the unknown variables V1 and V2. Once we solve it, the value of V1 is going to be equal to 40 by 3 volts, and the value of node voltage V2 is going to be equal to 20 volts. So that's it for the nodal analysis. That's how we calculate the node voltages as the unknown parameter. Now, once we know the value of node voltage, we can find any other parameter. So, for example, if we are interested to find the current in current value of current in 2 ohms resistor. So what will be the value? We know the current flows from high to low. So it is going to be V1 minus 0 divided by 2. So V1 by 2, substitute the value of V1, 40 by 3. We are going to get 20 by 3 amps of current. What about the value of current? Let's say, for example, like we are interested to find the value of current in 4 ohm resistor. It is going to be equal to V1 minus V2 divided by 4. So substituting the value 40 by 3 minus 20 divided by 4. It is going to be 40. This is 60. 20 60 minus 40. This is going to be minus 20 by 3 into, or maybe 4 into 3. So 4 it will go out, minus 5 by 3 amps of current. Now the value of current in the branch containing 4 ohm resistor is equal to minus 5 by 3 ampere. Now what do we mean by this negative symbol? The negative symbol simply means that the current is flowing in the other way around. When we started solving this circuit, we arbitrarily assumed the direction of current, and we assumed that the current in the branch with 4 ohm resistor is flowing from node 1 to node 2. But post solving and finding the current, we found out that in actual it is flowing from node 2 to node 1. So I hope you have understood the nodal analysis techniques to solve a particular circuit. That's it for this lecture. Thank you.